Hello everyone, welcome back to my channel. I am Sakshi Liber and here is the episode 7 of Learn DSA with Sakshi. In our previous videos, we learned about the singly linked list, its operations, and many more. Today, let's take it to a step further. We'll start by wrapping up the remaining singly linked list operations like inserting at a specific position and deleting at the specific position. Once that clear, we will shift our focus to the next level. We'll start the doubly linked list today. Unlike the singly linked list, where you can only move in one direction, doubly linked list allows us to travel in both forward and backward direction as well. This makes operation like deletion and insertion more flexible, but also slightly more complex. But don't worry about it, we'll learn it in detail. So stick with me as we finish off the singly linked list operation and dive into the world of the doubly linked list. So without wasting much more time, let's get started. So these are the topics we are going to cover today. Firstly, we will see about the remaining functions like insert at position and delete at position of singly linked list. And with that, we will complete the all functions of the singly linked list. And then we will start with the doubly linked list. So let's move to the Visual Code. So go to your folder. Till now, we have covered the 9 programs, and with this, we have completed with 6 functions like insert first, insert last, then display, then count, delete first, and delete last. Now let's make a new file and name it to program 10. Just copy your previous program and now let's start with the insert at specific position. So void insert at pos. So this is the basic structure of your program of this function. In our previous functions, we have used 1 or 2 parameters, right? But in this function, we have to use the 3 parameters. First will be the pp node head, then second is the int no, and the third one will be the int IPOS, means the position where you want to insert the node. So just write it, pp node head, int no, it is similar as the previous one, and the third one is different, IPOS, right? So this will is the parameters. PP node head, that is pointer to the first node of the list, that is addressed to the head pointer. Then int no, the data you want to insert, right? And the int IPOS, position at which to insert the new node. Then we'll start by writing the code. Now let's take one variable, that is count node, for count of the all nodes of the linked list, and initialize it to 0. Then we will also need one pointer which will be used in the further program. So now just take it and just create 2 more pointer. First is the new one, this is as the previous one, and initialize it to null. Similarly, second, name it to tame. This will be used in the further programs, and at that time I will explain you. And this also initialize to null, right? Now count node is equal to count of star head. Count node equal to count of star head. This line counts how many nodes currently exist in the list using the count function, right? Above we have declared, yes, this is the count function, and we have reused it in this. So this tells how many nodes currently are in your linked list. So this is for the counting purpose. And then we'll write one filter which tell us the position in which we have to insert the node is valid or not. So for this, we are going to write one filter. If the position is less than 1, then it is invalid position. Similarly, if the position means, let's say we have 5 nodes in our linked list and we have to insert at sixth position, then it will be more than the nodes, that is count plus one, right? So these two condition will be invalid. So for this, let's write filter. If IPOS is less than one, we need to write two conditions. So for that, I'm using the or operator. Means if any one of these is true, then it will be invalid. Then if IPOS is greater than count node plus one, then print invalid position, right? And simply return from it. So this is our filter, which checks if the position which we are going to insert is valid or no. Now, after checking this condition, we have three more conditions. Means if the position is one, if the position is last, or if it is in the end. Insert at position means we can insert at anywhere between the linked list. We can insert at the first position also, we can insert at the last also, and anywhere between the nodes also. Then just write this three condition first. If I pose equal to one, then its condition or its logic. If this, else if I pose equal to. So I pose equal to one means it is at the first position, right? And similarly, if we have to write at the last, then we will use count node plus one. And if it's not the first or last, then it will be definitely the else part. So I have just created the structure of these three conditions. Now let's see its logic one by one. So first we'll see if I pose equal to one. If the position is one, just call the insert first to insert at the beginning. We have used or create insert first at the beginning, right? So just simply called it insert first and pass the parameter head and number, right? It is as simple as that. If the position is first, just call the insert first. Similarly, if the position is at the end, means if inserting after the last node, which is means the end, at the end of the linked list, just call the insert last. Insert last and just pass the parameter head and number, right? Now let's see the main logic of inserting in the middle. If we want to insert in the middle, then obviously we need to make a new node first and assign it data index to it, right? So just make a new node, new n equal to. I just simply copy paste it from the upper part. So we have dynamically allocating memory to our new n, then assign data and next to it, right? Now here we have created one temporary variable. So here I allocate memory for the new node, then assign the given data number to it, and then set new and next equal to null for now. So this part we have seen previously also, right? Now let's take temp equal to star head, starting from the first node of the list and storing the address of the first in the temp. Then we need to travel the linked list to see where we want to insert. So for this, I'm implementing the for loop and just starting with the one. Here I declared int variable, int I equal to 0. Then I is less than equal to, it will be I pose minus 1. Why it is 1, I will explain it and then increment the load. And then we'll update the temp as temp next. So this loop travels the list until the node just before the target position. I'll explain it by giving an example. The purpose of this for loop is to move the temporary pointer to the node just before the position where we want to insert our new node. Means it helps to find the new node that will point newly to the inserted node. Now, why I pose minus 1? Because we need to stop at the I pose minus 1 position because the new node inserted is just after the node of the position and we want the temp pointer to be 1 that will link to the new node. Let's draw a diagram for better understanding. Let's say we have 3 node in our list. First, then second, and third. Let's say its element will be 11, 21, and 51. And read, and here null pointer. Head is pointing to the first node. Then these are connected in this way. And at the end, it is pointing to the null. Now, let's say we want to insert 75 at position 3. So, its position is 1, then it's 2, and it is at third position, right? So 11 at first position, 2 at second, 21 at second, and 51 at third position. But now I want 75 at the position 3, means after 21, I want 75. So for this, first, according to our code, count node is 3. There are 3 total number of nodes. Then the new node to insert at the third position. So I pos equal to 3 and count node equal to 3. Then now the loop will run for I is equal to 1 to I pos minus 1 means here I is equal to 1 and I pos minus 1. I pos is 3, 3 minus 1, 2. So loop will run for I equal to 1, then I is less than 2, then I plus plus. Right. So the first iteration I is equal to 1. In this iteration, our temp is initially pointed to 11. Right. Then temp equal to temp next. In our code, if you have seen, after the for loop, it is entering in the for loop, then temp equal to temp next. This moves temp to point to 11, means second position. So after it will increment to then I plus plus, then I becomes 2. When I becomes 2, temp is now pointing to now temp is pointing to 21, right? And then after entering into the for loop, temp equal to temp next, means it moves to the 51. At this point, temp points to the new node 21, which is just before the inserting point, which is just before the inserting. Now we have to insert, like say, 75 here. Now we can insert 75 new for this. Now first write the remaining code and then we will move toward the diagram. So after the end of for loop, for inserting the new node, new and next is equal to temp next and temp next equal to new one, right? Now let's understand these two lines by the diagram. So I have drawn a new diagram for better understanding. So in the first iteration, temp is 11 and temp equal to temp next is 21. So this is for the for loop. And in the second iteration, when I becomes 2, temp is pointing to 21 and temp equal to temp next, then temp is pointing to 51. So this is the position we have reached where we want to insert. We have to insert here in third position, right? 11 is in first position, 21 in second position, and 51 in third position. So we have reached here successfully. So now the for loop's work is completed here. Now let's move to the this part. When new and next equal to temp next means now our new and is temp next means it links the new node. New node data is 75. So it links 75 to the 51. So this first line links with 51. I'll just like link to 51. And then second line, so now it will be like this. And second line is temp next equal to new n. Now in this position, temp is 21, right? So now temp points to the new node, which is the 75. So now this will link to this, and this will be deleted. So by these two line, we link our new node to the next node and temporary to the new node. So in this way, it will work. I hope I understand you this insert pose function better by with the diagram. So after the insertion, our list will be 11, then 21, then 51, sorry, 75, and then 51, and then pointing to null. So I hope this clarifies you how the for loop works and how we insert the new node um, at any specific position. So this is all about the insert function. Now similarly, we will write code for the delete position, and then we will call it from the main function. So for this, similarly write one delete function, delete at position, and then we will write its logic. Delete at position function is responsible for deleting a node at a specific position. The position is provided as the input by the user through IPOS, similarly in the insert position function, and the function perform the deletion accordingly. Now we will see it step by step. So for this, again, it will not take three pointers as delete function takes only one pointer, sorry, one variable, that is pp node head. So now instead of taking the three, just like in the insert position, it will take only two parameters, that is pp node head, and second is the int position. No need of the int no, as we want to just delete. So this will be the parameter. pp node head is pointer to pointer head, and in position which need to be deleted. Now let's write the code. Starting with count node, it will note the count of the node, then one counter and initialize it to 0. Then we will take two pointers. One is temp, initialize it to null, and then we will take another pointer, name it as target, also initialize to null. Now let's write the actual logic of this function. First, write the count node is equal to count of star head. This function first calculates the total number of nodes in the linked list using the count function. Then we will, just like the insert position function, first we have counting the nodes, then we'll create one filter, and after that checking condition one by one. So now let's write the filter. I just copy paste it. Its condition will be different, right? So what will be its condition? See, the IPOS is less than 1 is the first condition which needs to be true in this case and insert case also. But IPOS is less than count node plus 1 is not true here. Why? We just need to write count node here, right? This step checks if the given condition is valid or not. A valid position should within the range from 1 to the total number of count node. Right. If I pose it outside this range, this function print invalid message and exit from it. Now let's clear one common doubt. Why we use count node plus 1 in insert at position and just count node in delete at position. Uh, when we insert a node, we allow position count plus 1 because it means adding the node after the last node is totally okay and it is valid. We can add node at the last. But at the time of deleting node, we allow only up to count node because we can delete only the node that actually exists. Count nodes give us the count of the total nodes in the linked list. Let's say it has 5 total nodes in our linked list. And if we say here count node plus 1 instead of the node, then it will be at the sixth position, right? When sixth node is not actually existing, then how can we delete that node? It is totally useless. So for this, we just need to write the count node. So in insert at position, count up to the count plus 1, and in delete at position only up to the count node. It simply checks, but super important to avoid the errors, right? I hope I clear this out. Now let's move further. Now we are handling the three cases similarly like in the insert position function. If the position is 1, if the position is last, or if the position is middle. So for this, just write if I pose equal to 1, then what will be its condition? Then else if I pose equal to count means last, and then else condition. Mhm. If not, then else. Now we'll see its logic one by one. So the first case is I pose equal to 1. Means if the condition is 1, that is the first node, then call the delete first function, it will delete the first node. So just call the delete first and pass the parameter. And it requires head only, right? So this is about the first position. If the position is last, means if you want to delete the last node, then just call delete last. It is same as we have done in the insert first, where we call insert first and insert last. See? Similarly, we have done it in delete position function. Now, if the node is to be deleted is neither the first nor the last node, then the function proceeds to delete the node at the specific position by this step. First, it will traverse the linked list until the node just before the one to be deleted, that is IPOS minus 1, right? And we have seen this logic in the insert first function. Then, using a temporary pointer temp, the function moves from the head to the node at IPOS minus 1. After reaching to them, the node at IPOS, which is referred to as target here, is then unlinked from the list by setting the next pointer to the previous node to point to the node after the target node. I know this is a bit confusing, but don't worry. We'll see it by diagram so that we can understand it easily. And then after we get the target node next, then we will finally free the target node from the memory. So now just implement its logic and then we will see it through the diagram. So first temp equal to star head, then for loop for I is equal to 1, then I is less than I pose minus 1 to reach at the desired position, then I plus plus, and updating the temp here, temp equal to temp next. Then after updating the temp, we have target. So set target as temp equal to next, temp next. Then temp next equal to target next. And at the end, just free that target. So from this, it move node just before the target node, and this line indicates the node to be deleted, means target, and this line unlink the target node from the list, and at the end free the target node from the memory. Now just understand it by diagram. Now let's say we have 6 nodes. First, second, third, fourth, fifth, and sixth. Firstly, I'll draw the whole diagram, then I'll explain to you. So here is the diagram for the insert at position function. Um, Here I created a linked list of 6 nodes, and let's say the user want to delete the node at position 4. So I want to delete 101 node. And then How it works? So firstly, it will calculate the total number of nodes, which is 6. Then, so according to our code, firstly, it will count the total number of nodes. That it will check the condition is valid or not position, which we have to delete. Then checking the three cases. First, if you want to delete the first node or the last node. As we want to delete the fourth node, it will implement this else block. So first will temp is equal to star head. So in the first condition, our temp is pointing toward the 11th. Then um, in the for loop, it starts from the first iteration, and inside the for loop, temp is updated to temps next. So when I becomes 1, when I becomes 1, so temp is pointed to 11, and temp next is equal to, so temp is pointed to, so just wait a minute. So temp, right. So first temp is pointed to 11 when I is equal to 1, and temp next is pointed to, let's create temp next also. Create temp next here. So temp next, right. And temp next will point to 21. So this is for the first iteration. Then I plus plus, I becomes 2. When I becomes 2, temp next is pointed to 21, and temps next pointed to 51, right. When I, then I becomes plus plus, means I becomes 3. When I becomes 3, so when I becomes 3, our loops get stopped because 4 minus 1 is 3, and in this condition loops will stop. And so we have reached the condition, and here we want to, and here is the node which we want to delete, right. That is 101. Now the temp is equal to 51. So it is perfect. Then we have set the target as the temp next. So then target will point it to 101. So this is our target. So this is our target, which is pointed to 101. Then temp next equal to target next. So this temp next equal to target next is 111. And then we will finally free this memory, right? So this is the diagram of before node deletion, and when we get the target, now we get our target, that is 101. Now we get our target, so we link target next. It means we link this to this and then simply deleting our target. So after deleting the node at position 4, our linked list will look like this. So this will also deleted. This is also deleted, and this will also unlinked. And the new link will look like this. So now 51 is directly linked to 111, and this is done by these three lines. And at the end, we free the target. So in this way, how delete at last work, right? If you want the diagram, here is the diagram and full explanation of it. Just do one thing, draw it yourself and explain it so that you will get it better, right? So that's all about the linked list. So far, we have successfully covered all the core functions of the singly linked list, like the insert first, insert last, insert at position, then delete first, delete last, delete at position, display, and count. Each function taught us how to work with the pointers, manage memory using the malloc and free, and carefully update the links to maintain the chain. As we completed the insert at position and delete at position functions, now let's call it from the main function. So I just delete all it and just want to um, show the output of the insert at position and delete at positions for this. This is the code where I insert the three elements at the first, then inserting three at the last, then call the insert at position. I want to insert 75 at the fourth position, and then it will display it. And similarly, I want to delete the element at the fourth position. So this is the code for the calling function. Now just save this and open command prompt. Go to your directory, then type gcc program 10.c, then minus or my exe. Sorry, it gives you error. So okay. So here I mistakenly write null. It should be zero. Sorry. So now just save your program and see the yes. So the previous linked list means linked list after insert at position is this, and number of elements are 7. 11, 21, 51, 75, 101, 111, and 121. And number of elements are 7, and we insert 75 at the fourth position. Then the linked list after deleting the fourth position element, that is 75, it is like this. So this is all about the linked list, single linked list. If you want this code, just I'm giving it to you. So this is the overview of the code. Just go through this once. We have covered all the 8 functions which we have learned in our first or second video, I think. And here is the delete last, then insert at position, and this is the delete at position function. And from the main function, we call it. So that's all about the singly linear linked list. With this, we have mastered the fundamentals of singly linked list, where each node points to the next node and we move only in one direction. Now it's time to move a step ahead. So we complete the singly linked list. Now let's move toward the doubly linear linked list. So let's begin with the doubly linear linked list. Now let's start with the doubly linked list. In doubly linked list, each node contains the three things: the data, the pointer to the next node, and the pointer to the previous node. So here is the diagram. As it contains three sections. So first is for, let's say, data, then second for the next pointer, and let's say for the previous pointer. So it has data, next, and the previous node. And this doubly linked list allows us to traverse in both the directions, which makes certain operations like deletions, then or backward traversal much more efficient and flexible. So we will learn about everything about the doubly linear linked list, like its delete first, delete last, insert first, insert last, then display, count, and insert at position and delete at position, similarly like the singly linked list. And we will understand each functions line by line with proper diagram and logic. So, and here I'll draw one diagram for the doubly linked list. Let's say our doubly linear linked list has three nodes, and each one is connected in this way. So it has next pointer also and previous pointer also. And then that's right. So this is our doubly linear linked list. So let's start the coding of the doubly linear linked list. The logic of the doubly linear linked list is almost same as the singly linear linked list. The structure and flow are very similar, but with some minor changes in the logic. So you don't need to start from the scratch. If you understand single linear linked list, doubly linear linked list will be feel like as a simple upgrade. So for this, just make a new file, program 11.c, and just comment it as doubly linear linked list, so that you will get which code is of which linked list. And here you comment as singly linear linked list. So just copy the code of the singly linear linked list, and we will make changes in this code also. In this video, I'll just upgrade the program of the singly linear linked list. And in the upcoming videos, I will explain it line by line. So now just look at what we need to add in the singly linear program, or what logic is changing. Today, I'll show the singly linear versus the doubly linear code. And in next video, I'll explain to you. So program 12 is the program of the doubly linear linked list, and program 11 is the program which we are actually upgrading. So I'll just delete the window. So, so here are the both the programs. So we'll just see it. Actually, I make some changes in this program. So just open the 10th program. Yes, singly linear, and this is doubly linear. So what changes are introduced in these both? So first of all, in the struct node of the doubly linear linked list, previous node is also added. So for that, we need to add this line, that struct node star previous. Then the type def is remaining same in both. Then insert first, pp node head, all it is remaining same. Just we need to add the new and previous equal to null. This line will be new here. Then if you can see, first case is similar in both. And in the logic of the else part, only this line is added. How, what does it mean and all, we will see it later. And then in the insert last, then again we need to add this previous and initialize it to null. Then just adding new one line here, and then it's the program for the doubly linear linked list. Then the display and the count function. Display and count function remain as it is, just we use some decoration part here. So it's not actually changing the code. It is as it is, like the singly linear linked list. So display and count function remains as it is as of the singly linear linked list. Then moving forward, then delete first. In delete first, see, first and second case remain as it is, no changes at all. Just in the third condition, we need to just add these two statement, and that's all. And it will update to doubly linear linked list. And then delete last, just case 1 and case 2 is remain as it is. Just need to update the case 3. Then moving forward to insert at position. Yeah. Then again here, everything will same, just we need to change the else part. Nothing else. See. So we just need to add these new and previous. Then just add two more statement. First is this one and second is this one. And then for the delete first also, we need to change the else condition. See, we need to change only the else condition, and that's how it is. So that is how doubly linear linked list is. I'm just closing this. So here is the best part. If you have understand the singly linear linked list, then learning doubly linear linked list is going to be super simple. Why? Because the logic is almost same. And as you saw that both of the programs are set, just we need to add some lines extra to the code, and that's all. and you need to just make minor changes. One, add extra pointer that is previous to all of them where we need the next, where we add the next, just add the previous to there and update the previous in insert and delete function. That's it. Everything else like traversal, then memory allocation, logic flow remains just like the single layer linked list. So don't worry, you are not starting from zero. You are simply leveling up your linked list skills. So that's all about the linked list. So that's it for this video. We have completed all operations of the single linear linked list. I hope everything is crystal clear by now. And in the upcoming videos, we'll start with the doubly linked list code explanation step by step. So stay tuned and don't forget to like, share, and subscribe to the channel. Thank you so much for watching. See you in the next one.